All right, having studied functions, there's actually a few different ways we can represent functions. So algebraically, tabularly, verbally, and graphically. So we kind of focus on the algebraic perspective last time, right? We saw equations and symbols and that sort of thing, but now we're going to try and move between the different forms of a function as well. Okay, just remember that the overall definition of a function is that every input, and I have it in italics here, every input is assigned to exactly one output. Okay, and so if we think about that and maybe switch that graphical perspective, right, that means that if we think about one input, that's every x, right? Every x has exactly one output, and so we would see for every x there's one y, right? And so that gives rise to the vertical line test, okay? And the vertical line test just says that every vertical line passes through the graph at most once for a function. And so if I think about that test, right, if I try and, look at these things and say, okay, are they functions? I am trying to say, okay, well, let's take a vertical line through them. Okay, oops, it intersects at two places, right? So this is not a function, not a function. By comparison, if I take a vertical line through any place on the function on the right, or the relation on the right, and its graph, it would pass. So this is, yes, a function, because it passes the vertical line test. Okay, and so as we get more experience, we're going to be able to say, yep, these things just based on sight are going to be functions, and they happen to coincide with the graphs of these 8 functions. Those are kind of what we're going to call our base graphs when we get into them in Math 1120. And in class, we will have you go through and, what does the graph look like? What does the table look like? What do the words look like? And then also identify properties, domain, range, intercept, all that good stuff. So more on that in class, okay? But at a base level, if you recognize it corresponds to one of the forms, right? You can say, okay, well, I have the overall idea of what it looks like. Maybe I just need to generate the specific graph using a table of values. For instance, right, you might recognize that the absolute value is in here. So then you're thinking, okay, the graph's going to look like a V, but what does this specific one look like? Well, I would say, or right now for the beginning, right, I would say let's pick just some nice x values. I typically do -2, -1, 0, 1, and 2. And then I run those through the equation. So I'd have, this is -2 times the absolute value of -2 plus 1, which, let's see, that'd be -2 times 2 positive. So that'd be -4 plus 1 is 3. -3, my bad. So -2, absolute value of -1 plus 1, so that'd be 1 times -2 is -2 plus 1 would be -1, 0. Gives me 1. And then this should mirror, let's see, 2 times the absolute value of 1, -2 times the absolute value of 1 plus 1, yep, gives me -1, and then this ends up being -3. I'll let you verify. And so if I think about labeling my graph, I'll just go 3 in every direction. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, and so if I plot my points, -2, -3 down here, -1, -1, 0, 1, and then it would mirror. Okay, and so my function is going to look something like this. Okay, and so if you ever start generating a table of values and doing it that way, always is a valid method. Okay, and then also, as we look at the graphs now of more robust functions, right, we can identify other properties, right? Domain, range, etc. So let's just go through, and here is a function. I'll try and get it all on the same screen. Okay, so here's a graph of f of x, okay, and what I want to do is find the domain and range. Okay, so let's see, domain, and range, and then it says calculate f of 2. Okay, I can do that. So maybe start there. So domain is all possible x values, right? How far left do I go? How far right do I go? I have a smooth curve, so I'm actually going to utilize interval notation. So here I go I kind of start the function at an x value, right? Domain is all x's, at 1, and that is included. And then I progress to the right. I go to the right all the way until I hit or get close to 5, and I see at 5 there's an open circle. So 5 would be excluded in my using interval notation. Okay, range, I'm looking at the y values, right? So I start down here at -5, but that is not included, so I'd have -5, and then I would go up again. I'm looking at all the y values, and let's see, I have y values all the way up until here, and that would be included, so that'd be up to 4, and so my range would be -5 to 4 included. F of 2, okay, remember when we see the notation y equals f of x, right, that means x is the input into the function and I get out y as a result. And so this 2 here is an x value. And so when it's giving me this symbol, it's asking, you know, what is the y value when x is 2? So when x is 2, y is 4. Oh, that wasn't too bad. Intercepts, where does it hit an axis? Well, it doesn't hit the y-axis, right? But it does hit the x-axis at 4, 0. So I would say x-intercept is at 4, 0. And the last one is perhaps one of the most confusing. So we want to know the x values when f of x is equal to 3. Okay, so f of x is equal to 3. And so this 3, again, this is a y value, so I'm wondering, okay, when is y 3? So 1, 2, 3, 1, 2, 3, and I'm looking for anything that touches this horizontal line. Ends up touching right here and here, right? And then I just need to report the x values at those locations. So that would be when x is 1 and when x is 3. And so I'm just going to say, okay, here x would be equal to 1 and 3. And that's all I need to do. All right. So keep in mind that with a graph of a function, right, we can ask a lot more questions in a different way that we can with the equation.